Hi everyone. So let's discuss the partial fraction problems a little bit. So this is a problem that you have to use partial fraction. Now how do you know which ones? Usually the rational function where you can factor the denominators, okay? Now if you have a simple rational function, let's say something like x over 2 minus x squared. Well, you can factor the denominator, yes, right? But doesn't mean that this should be done with partial fraction. Don't immediately jump to that. If it's a simple looking function, think about it a little bit, right? Look, this is just a simple u substitution. Okay, here is your u. And when you take the derivative, you get negative 2x. So it's a du over negative 2. But it's just a simple u sub, right? Negative 1/2 ln of u, which is this. And done. So don't jump to partial fraction unless you see this is a complicated looking rational function and you can factor the denominator, okay? And then you cannot just do a simple u substitution, for example. Okay, I'm not going to do this whole problem. Look at my videos. I have done problems with partial fraction with different types, different level of difficulties, and 2 different methods of doing the algebra. But the main thing is, okay, whatever function you have, in this case, here it is. First thing that is very important is that you write down the fractions correctly, okay? One fraction for every factor, and if it's repeated, remember what to do then. Here nothing is repeated. Okay, for x we will have a over x. For b you will have for x minus 1 you will have a b over x minus 1. They're both linear, so you put constant on the top. But the last one is a quadratic, so you will not write c, but you will write cx plus d. And then the idea is you have to find a, b, c, and d, right? Doing the algebra. You add them together, then you have to take the 2 numerators equal to each other, then you can do the coefficient matching problem method, or you can plug in x values, okay? Now, what I really want to talk to you about is the integral part. So after you do all of that, you find a, b, c, d, now you have to actually integrate, right? Because that was the original problem. Question is, do you know how to? So that's the one, right? Okay, so if you have the linear ones, that's pretty easy. This is ln, right? This is ln, a and then ln. This is another ln, because it's just a linear. What do we do with this one? That's the one I want to focus on, especially. Now notice, this is x squared plus 2. So if you do the u sub like before, see the quadratic in the bottom, you do u sub, its derivative is just a single x. Well, with constant. Constant we can adjust, but it's just x. But look what you have in the numerator. You have an x term plus a constant term. So you could have something like, you know, like a negative x plus 3, something like that. Then you cannot just directly just do a u substitution. What you have to do is you have to split it up. Cx over plus d over. That's what I want to mention to you. Keep in mind, okay, if you end up getting something with both terms present, one x term and another constant, you split it up. Why am I splitting it up? Look at this one. What can I do with that one? U sub. This one is u sub. Because now on the top, there's just the x term, no plus. So we can solve that. Now how to do this one? There is just a constant. You can pull the constant out, and you will have a 1 over x squared plus 2. What is 1 over x squared plus 2? What did I just tell you in the previous video? Arctan. That's the arctan. Okay, you have to complete it, right? 1 over square root of 2, arctan x over square root of 2. But the point is to know how to solve an integral, to look at it and see, oh, constant over simple quadratic x squared plus a squared form, that is my arctan answer. So usually it happens. That's why I was telling you to memorize certain integrals and identify it, so that when you're doing a complicated problem, in the end, you don't have to spend more time solving it. You know right away, this is a u sub problem, this is a arctan.